So guys, as you can see, we have there, this is our PIC1 board. This is the transmitter side as well, the blue one. This is the receiver board. And on the receiver side, we also have the LCD. Now you can see the LCD is receiving the data. We receive A for longest, like for 2 seconds, then B for 1, then C for half a second. See, A is received for 2 seconds, B for 1 second, C for half a second. Now why this is happening? Now I show you the code for both the PICs. Now first of all, for the transmitter PIC, you can see that we initialize the UART port, then we check if the TX buffer is idle and we send A, character A. And the character A is sent for 2 seconds. Now for the B side, for B, we do the same, then we send character B for 1 second. Now for the character C, we send it for half a second. Now if you see the circuit diagram, this is the circuit diagram, this is our PIC, that is a transmitter PIC whose code I have just shown you. It has no other component, only it has a UART port connected to the second PIC, that is a receiver PIC's UART port. But the receiver PIC also has an LCD. So on the receiver side, this is the code. We initialize the LCD first, then we initialize the UART port, we initialize the LCD, then we checked whatever the data is received over the UART port using this command. Now if A is received, we just display this text called A received on the LCD, starting from first row, first column. For the B, we display B received. For C, we display C received. Now for how long the character is to be displayed depends upon the transmitter side. Suppose the character is sent A is sent, but after we pause the code, like transmitter is now paused for 2000 milliseconds, that is 2 seconds, we do not send anything else. So this means that the receiver side do not receive any other character, so the rec11 variable still have an A. So it will keep on displaying A for 2 seconds. Similarly, B for 1 second and C for half a second, because there we have given pauses. Like once B is sent, it pauses the code for 1 second. When C is sent, pauses the code for half a second. So this coding gives us this result over here. See, A, B, C. Now this is a demonstration of UART communication between two PICs and using an LCD to display the data on the receiver side. So this is, so guys, welcome to learning microcontrollers. In this video, we will be establishing UART communication between two PIC16F877A microcontrollers. We will send a character or a letter which will be our data from the one PIC to another PIC, and then we will be having a 16x2 LM016 LCD on the second PIC, and we will do our programming in such a way to display some data on that PIC's LCD using the indicators characters coming from the first PIC. So that's what we are gonna do here as an exercise. So let's get started. So guys, this over here is our first PIC, PIC16F877A, having 40 pins. It's a DIP version. Then this is the second PIC. It is also the same PIC. First of all, before we move further, we establish the UART communication. Now to connect these PICs together over the UART port, you need 3 pins: ground, TX, RX. Ground will go to the ground. Now the TX pin of the first PIC will go to the RX pin of the second, and RX pin of the first PIC will go to the TX of the second. So it will be like TX to RX, RX to TX. So for that purpose, we note that the pin number 26 of this PIC is the RX PIC, and pin number 25 of this PIC, that is a TX PIC pin. That is pin number C6 here is a TX, and pin number C7 here is the RX. So we connect them. So RX of this PIC goes to the TX of this PIC. Now it will be vice versa. Now the RX of this PIC, that is C7, will go to the TX of this PIC. So TX to RX, RX to TX. That's how the UART port is connected. These two PICs are connected, and now we can do the programming over the UART channel to send and receive data at the same time. Now guys, as I told you earlier, we will be having an LCD connected to one of the PICs. So we connect this LCD to this PIC. Since the LCD is connected to this PIC, we call this the receiver PIC, and we call this the transmitter PIC. Now guys, what we have to do? We just have to do the programming. The wiring of the LCD and then the programming. Now first of all, let me show you how to connect this LCD as well. As you can see, it's a 16x2 LM016 LCD, easily available in the market. Now you can see this is a 10K potentiometer. We need this to connect this LCD with the PIC because it will be used to adjust the contrast of the LCD. So you need this. Now it has 3 pins, 1, 2, 3, also mentioned on the body as well. You may use other type of potentiometer as well, doesn't matter, but these ones are more accurate. So I suggest you use the same. Now guys, for the LCD, you can see we have 16 pins on its body from left to right, 1 to 16. If you hold it like this, now guys, connect the pin number 1 and 5 of the LCD like this. Then you connect it to the pin number 1 of your potentiometer like this. From there you send it to the common ground. That will be the ground of the PIC like this. Then you will power up the PIC from whatever source you want. I will power up the circuit using my PIC16F877A. I also have a video in the introductory section like how to set up the hardware. You have to go through that video. In that I have shown you how to set up the hardware. Then you will do this connection. Like you will connect the PIC kit or you will power it up directly. That's up to you. So the next thing is the VDD, this pin number 2 of the LCD. You have to connect it to the pin number 3 of your potentiometer like this. From there you send it to the VCC pin of your PIC. In this way your LCD gets the 5 volt and your potentiometer gets the 5 volt. Now pin number 3 of your LCD is the contrast adjustment pin. You will connect it to the adjustable pin of your potentiometer. That will the pin number 2 in my case. If you have a different potentiometer, it might be pin number 3 or 1, whatever it is. Just connect it to that pin, adjustable pin. Now pin number 4 of your LCD is the RS pin. For the RS pin, you can use any available GPIO pin of your microcontroller. I'm going to use a pin number D1, that is pin number 20. For pin number 6, that is the EN pin, I will use a D0. Leave pin number 7, 8, 9, 10. I will tell you later why. Go for the pin number 11, that is data pin 4. Connect it to any available digital input output pin. I'm going to use the pin number D4 of my PIC for the data pin 4 of the LCD. For data pin 5, that is pin 12 of the LCD, I use port D pin 5 of the PIC like this. For data pin 6, it will be port D pin 6. For data pin 7, it will be port D pin number 7. Now these 4 pins 7, 8, 9, 10, as I have told you, we will leave them floating because they are used in the 8-bit mode. You can use this LCD either in the 4-bit mode or the 8-bit mode. If you are using this LCD in the 4-bit mode, you only need these 4 wires. These 4 are not required. So just leave them floating because in our application 4-bit mode is more than enough. So that's it. Now for these 2 pins, pin number 15 and 16, they are for the LCD backlight. Like this power, pin number 1 and 2 is for the LCD, like the data being shown on the LCD will get powered up from these 2 pins. These 2, even if you don't give them any, you leave them floating, still your LCD will work, but there will be no backlight. To make sure that the backlight turns on, you have to power up the LED using these 2 pins. So pin number 15 is the power, just connected to the 5 volt, 16 is the ground, just connected to the ground. In this way your LCD gets connected. Now guys, you can see this is our total hardware. This PIC will be the transmitter PIC. We will send a character from this PIC to this PIC. We will read the character over there over the UART port. Then we will display a certain text on this LCD based upon those characters, or we may display the characters directly. So whatever is preferred. So that's what we are going to do here. So guys, before we move on, let me introduce you to the hardware, then we move on to the programming. So guys, this over here is a simple hardware. You can see this is the LCD I have over here, and this is a receiver PIC, and this is the transmitter PIC over there. You can see transmitter PIC and the receiver PIC. Then I'm using the PIC3 to power up both the circuits. So that's simple hardware I have over here. So guys, we have the hardware ready. We have our PICs ready. Now we can move on to the programming. So guys, this is our micro C4 PIC. Let me zoom in. I also have a lecture on this, how to download and install this for free. You can just go through that. Click on File, New Project. This window pops up, New Project Wizard. Click on Next. Write the name of the project, whatever you prefer. So first of all, we program the TX side. So I just use the same name, PIC2 PIC TX C4 code 4. Select the path where your hex files will be created and all other files as well. Select the microcontroller. I have PIC16F877A, and the crystal I have on the transmitter PIC is 20 megahertz connected to the pin number 13 and 14. Click on Next and Finish. So guys, this window pops up. Before you do anything else, click on File, click on Save your work. Now guys, as we know, first of all, we have a UART port to initialize. So go to the right in the micro E libraries. You have to expand it. The system libraries, expand it. Go down. There you have this UART, check mark this, expand it. There you have this UART1 I90. Double click on this. This window pops up. Go down. In the example here, you have this command, example, copy this, paste it in the one-time loop like this. Now this is the command to initialize the UART port. So we will initialize the UART port of the transmitter PIC with a baud rate of 9600. So we give some initialization delay, not necessary, but I always suggest you give it in the one-time loop. So 200 milliseconds will be fine. Now we go for the forever loop. I write while 1, forever loop starts here, ends here. We make it look presentable. Now guys, go to the right. For the transmitter side, we have to send some characters. So I use this command UART1 write, this one, double click. In the example here, you have this command UART1 write data. You paste it here, and whatever the character, this command can only send a character. So a single character, a char. So we send A. Now to send it in a secure way, like this command will send that data. In case the TX buffer is not ideal, it will try to send the data and your code will hang. So you have to do this. Go to the right, you have this command TX ideal. You go, in the example here, you have this command UART TX idle. You paste it over here and close the bracket over here like this. Now guys, this command makes sure that it will check the TX buffer of your transmitter PIC's UART port. If the TX pin is ideal, only then it will send the data, else it will skip and make sure that the buffer gets ideal. In this way, your code will never hang. Now, once we send A, we will decide for how long the A is sent, like for how long there will be the effect of A character A. Because once the character is received on the receiver side, we will program the receiver side in such a way that the effect will remain there. That variable will remain there in the same variable. We will store these characters in the same variable. So we send it for like, it will send character A and then it will pause the code for 2000 milliseconds. After that, we send character B. Copy all this, paste it here, B, but we send B only for 500 milliseconds. Okay, then we send another character C or whatever you prefer. I'm just writing a code for exercise, so we send a C and we send C for like only, okay, we send B for 1000, A for 2000, B for 1000, C for 500 milliseconds only. So this is the code for the transmitter side. Then we will do the receiver side coding. I built this code, no errors. Okay, let's burn this. Go to your PIC16 programmer tool. This is the PIC16 programmer tool. This is the hardware. Make sure that the PIC is connected to the transmitter PIC like this. See, the PIC is connected to the transmitter PIC. Now I click on write. Go to your PIC16 programmer tool, click on file, import hex file. This is the file we just created. Click on write. Okay, the new code is being written for the transmitter side. In the meanwhile, we go to our PIC micro C4 PIC and start writing code for the receiver side as well. Okay, go back, click on file again, click on new project. This window pops up, new project wizard, click on next. Change the name from TX to RX. Okay, this will be RX, rest will be the same. Path where your files will be created, like the microcontroller, I'm gonna use a PIC16F877A. The crystal connected to your pin number 13 and 14 of your receiver PIC. I have a 16 MHz crystal. Click on next and finish. So guys, this window pops up. Press Ctrl S to save your work like this. Now guys, first of all, again, we need to initialize a UART port. Go to the right. In the micro libraries, go down. There you have this UART. Click on it. There you have UART1 init command. Double click. This window pops up. Copy this command from here. Go back. Paste it in the one-time loop. Now this command initializes the UART port of your receiver PIC, and the baud rate should be the same as of the transmitter PIC. That was the 9600. See, on the transmitter side, we have set the baud rate 9600. It must be same here as well. So it's same. We give some initialization delay. Not necessary, but I always suggest you give it in the one-time loop. Now guys, we have our UART port initialized. Now we also, as per this diagram, you can see that we have the LCD connected to the receiver side. So we have to initialize this LCD with this pin out setting. So now go to the right, go to the LCD library. There you check mark this, expand it. There you have this LCD init command. Double click on this. This window pops up, and in the example here you have these commands. Copy them till here. Now go back, place it in above the void main like this, and here guys you will define your pinout setting. Like in my case, I have selected for the LCD RS pin, I have selected pin number D1. See, I show you on the hardware. Remember, when I was doing the wiring, I selected D1, this one, to the D1 to the RS pin. Pin number 4 is the RS, I connected to the D1. Similarly, whatever the pinout you have selected on the hardware, you will do it over here. So for the RS, it's D1. For EN, in my case, it's D0. For data pin 7 of the LCD, I have port D, pin 7. For data pin 6 of the LCD, I have port D, pin 6. For data pin 5, I have port D, pin 5. For data pin 4, I have port D, pin 4, like this. Now this was the LCD pinout, and this is the LCD direction. Do exactly the same here. RS, D1, D0, D7, D6, D5, and D4, like this. So D1, D0, D7, D6, D5, D4, D1, D0, D7, D6, D5, D4. Now again go to the LCD UART or LCD INIT command, like this. In the example here, now below these commands you have this command LCD INIT. You have to copy this, go back, paste it in the one-time loop, like this. Now this command will initialize the LCD with this pinout settings. So that's it. We give some initialization delay. So in this way our LCD is initialized as well. Now we go for the forever loop for our receiver side, while 1. Now in the forever loop for the receiver side, as you know, first of all we have to read the data coming from the transmitter side. Like we will read the data, then we will display it on the LCD. So first, to read the data, again go to the right. On the right, go to the UART library. In the UART library, you have certain commands. So in the UART library, you have this command, UART1 read. Double click on this command, like this. This window pops up. This is the command. You copy this command, this one, go back, paste it here, like this. And this is the variable storing the data. You may write any variable. I write char rec11, like this. This will be the variable which will store the data coming, and it is a char. It can store one data at a time because we are sending the charge on the TX side. You can see that they are just chars, A, B, or C, like this. Now we check if rec1 is double equal to, suppose we have received A, then what it should do. We have the LCD connected, we will display something on the LCD. So go to the right, in the LCD library, you have this command called LCD out. This command, double click on this, this window pops up. In the example here, you have this command LCD out. You paste it here. Now this is the syntax of the command LCD out. Start writing from the first row, first column. What it should write, A received. Okay, it will just display A received. Now else if, copy this here, if received is B, if we received B not A, then again we do the same, but this time the LCD will display received B, that B is received. Similarly, just copy this again, paste it here. Else if C is received, we are doing polling. This is the polling method. We are just doing the polling, that whatever the poll is polled. So if the C is received, it will display C at the same place, like this. So this is the simple code. So if A is received, it will display A. If B, C, C. Now for how long it will be displayed, that depends upon the transmitter. Like, see, these delays will be important. Like, I want this command to be displayed for 2 seconds. That's why on the TX side, I have sent it for 2 seconds. So it will keep on displaying received A because A is received. Once this variable, see, we have a single variable for receiving the data. So whatever the value received over the UART port, we have only one UART port is stored in this variable. And then we check this variable. If A is received, then A is received. It will remain A for 2 seconds because we have not sent anything else. Like A is received, it will remain A and it will keep on displaying this for 2 seconds. If B is received, it will remain B for how long the B is sent from the transmitter side. Like B is sent and then nothing else is sent, it will remain B. And if C is sent, it will remain C. See, in the code we are not like resetting this variable. It remains whatever it is until the PIC is not powered off and powered on. So in that case, that's how we will give delays from the transmitter side. We will not give delay on the receiver side. These delays will decide for how long the variable for the certain character is to be displayed. For A, it will be 2000, and that's on the transmitter side. C. For B, it will be 1000, and that's on the transmitter side. And C, it will be 500. So we build this code, check for errors, no errors. Now I remove the packet 3 and connect it to the other side, and we burn this code as well. So let's remove the packet 3 from that side. Okay, there I go. Okay, packet 3 is connected to this side now. Now I burn this code as well. Let me zoom in, click on file, import a hex file. This is the file we just created. Click on write. Okay, the new file is being written. We wait until it's written. We have to wait. Wait. Okay, there you go. It's done. Power up the circuit using the PIC16 programmer 2. I click on. Okay, it's on. Now see, we are receiving the data as per our expectation. See, A, B, C, A. Now see, the A is received for longest, that is 2 seconds. Then B, then C. B, then C. See, A is longest, 2 seconds, then B, then C. A, B, C is shortest, because see, now these timings are important. That's what I want to show you, that the transmitter can decide for how long the receiver may receive the data. So this is basically just a demonstration of UART communication. You can use the loops as well, like you keep on sending one character for 2000 times to make sure that it's sent for 2 seconds, or you can use the timer or an interrupt as well. So this is how you basically use these commands to play with an LCD and to establish a UART communication and to display data on the LCD. See? So this is it, guys. If you guys have any questions, you may ask. We'll see you in the next lecture. So goodbye until then.